Viewers, welcome back to my channel Tune to Linux. In this video I'm going to discuss about LVM mirroring, and for the basic what is LVM and how to create LVM and file system, please check my previous video. Okay, so for this video I'm going to discuss about LVM mirroring and the benefits of LVM mirroring. Okay, so before starting about mirroring, I need to tell you basic about what are the types we have. So mirroring comes under a RAID. Okay, so we have RAID 0, 1, 5, 6, 1 plus 0, and so on, right? So here we are going to use RAID 1, so which is called mirroring. So now what is mirroring? So mirroring is nothing but your fault tolerance. You can use minimum 2 disks, and you can mirror it between these 2 disks, and you can use more than that. If you would like to use 3 disks, you can go ahead and use, but to configure mirroring you need a minimum 2 disks. Okay, so in production environment it is very much useful. Why? Because for example you have one disk 10 GB and also another disk at 10 GB, and you are writing a data. You have a LVM with the size of 10 GB, because since I'm using mirroring here. So, and now if some data corruption or this disk failed due to some reason, the first disk is failed due to some reason, but you have still the other disk and you have all the data available in this disk. So that is the main purpose we use LVM mirroring. We also have a good performance to write data in LVM mirroring. That is the second reason we use. And nowadays it is very much important to use mirroring, because for example you have a data center in a location, and you have another data center in B location. So there is a disaster happen in your data center A location. Something disaster happen and all your data center got damaged, and you have lose all the data which is coming from this data center. But when you have mirrored this from different data center, one LAN is from this data center and another LAN is from different data center. So if this side is totally goes down, we have still the other data center available, and we have still your business up and running. So you do not have anything, it will not going to impact anything in your business even though there is a disaster, right? So in that case it is also very useful. So we can assign two different LAN from different data center, one LAN from data center A and one LAN from data center B, and we can mirror it from OS end, and that will provide you disaster recovery. That will provide a disaster recovery survival, right? I mean your data will be still there if is a real situation happen. So that is one additional benefits which we use in real time. And another additional benefit is you are using an EMC storage, right? And now this is costing much. You wanted to move out EMC. I'm just giving an example, okay? It is not like EMC is more expensive. So EMC is costing more, and you wanted to go for a cheap or other storage type which is coming a little low budget than the EMC storage. Just an example I'm giving here, an IBM storage. So there is a way of replicating data from storage end, but there is a lot of cost when it requires to replicate data from one storage to another. Believe me, there is a lot of cost. Okay, so they need many things and license and stuff, and there is a lot of cost involved. So in that case, it is very much useful the LVM mirroring when we do from the OS end, right? So now you have one LVM. For example, you have one file system called data LV, that LVM you have created, and the LUN is EMC. And now you wanted to get rid of EMC. So what you will going to do, you will assign a new LUN from IBM storage, and you will mirror it in LVM level. And once you mirror it, break the mirror and remove the EMC LUN from your system. So what it will give, it will give you 100% availability without involving any additional cost, right? So those are the main reason we use LVM in real-time production environment, and it is widely used. Okay, so let me first tell you how to create that. So currently I don't have any LV, but I have some PVs. So I'm going to create a mirror LVM with these two disks. So it is already formatted as PV, that's why it is showing under PVS command. And I will going to create a VG create, for example mirror VG, and disk is SDE and SDF, right? So SDE and SDF. You can use command chaining, giving a semicolon, and you can create LV create and minus L, and you can use, for example, about 512 MB, mirror. Let me do one by one. I think it would be a confusion if I do like this. So now I have one VG created, so it is around 2 GB. So let me create an LV create minus L 512 minus N mirror LV data LV, mirror VG. So I'm just creating a LV with the size of 512 MB. Okay, so it is created and it is active currently, and now I'm going to mount it. Before mounting, I just need to format this one, right? So let me format to, it is mirror mkfs.ext3 mirror. So it is formatted. Now I will mount it. Okay, so because it is now mirror, not data vg. Okay, so let me try to mount, and now my file system is mounted. But if I do VGS or PVS, I can see there is two disks in VG, mirror VG, and if when I do a VG display minus V mirror VG, I can see this disk SDE is used, and currently it is free PE is 127, and the other disk is totally free. Out of 255 is free, right? So now I'm going to convert this linear LVM to mirroring, right? So currently if I do a LV display slash dev mirror VG mirror LV, and now I can see basic information about my VG, and also here if I do, I can see some information about my logical volume, and the disk is available here, right? So I need to convert it to mirror now, right? So before mirroring I just need to run this command lvs, and you can see here this is the LV name, this is VG name, active O for open, which is mounted, and this is the size, original data, move data, and you can see one option called copy percentage. So here it will show your whether your LVM is mirrored or not, and whether it is totally sync, and what is the sync percentage. So it will show here. So currently, since it is a linear file system, not mirrored, that is why there is nothing here. So to convert it, there is one command called lv convert minus help. You can check many options here. What are those options? -s for snapshot, minus merge, and there are many options we have available. I'll tell you what are those options when I'll show you the other things. Okay, for now lv convert -m, okay, for mirroring, and level what mirroring level, red level we are using is 1. So here it is 1 m1, and here we need to specify the core log, right? Why we use core log, that is also one question. So let me man lv convert core log. So here the option argument core log is the same as specify the mirror log core. There is one more option, mirror log, also you can specify, but why you use core log, that is let me see. Okay, so anyway, it will take some time to find it, so I'll tell you what is core log is. It will just take some space from your memory and swap when it is converting from linear to mirror. That is why we use this core log, and inside this there would be a mirror copy, so that is why we need to use core log. Okay, so lv convert minus m1 minus core log, and also you can specify b, which is for background. If you do not specify -b, then you will not get the best prompt, and until your sync is complete you won't be able to do anything, right? So that's why I want a console and best prompt once I execute this command. That's why it needs to go to background, so that is why I'm specifying this. And let me specify the LVM which I'm going to mirror and the disk with whom I'm going to mirror it. So currently this disk is free, so I'm going to mirror with this disk, right? So this is what you require. Just run this command and now you can see LVM volume mirror LV is converted, and because of -b it is syncing in background. So how will you see the status? Just run LVS and here you can see the copy and sync status about your mirroring, and you can also see one flag come here as mirroring. And if you wanted to see and details about this, then you can just need to do a device and grab it for this mirror VG. Okay, so here you would see the first copy, this which is this disk SDE, and the second copy for your mirror, it is running on this one. So it is pretty much simple and straightforward. So this is how you have to convert from linear to mirroring. So now I have this file system, and inside this file system let me touch for some file A 1 2 3 4. Okay, so there are 4 files, and some reason your first disk is corrupted, which is this one, and you wanted to replace this disk or remove this disk. So for that what we will have to do is, instead M1 we have to do M0, LV convert minus M0, which will revert back from mirroring to LVM linear, and then you don't have to specify in background because it will not going to take the mirroring, and mirror VG, mirror LV, right? And you wanted to remove this disk because this disk is faulty. So I'm just specifying this the disk, enter, and now you can see it is converted. And now if I run this command, I can see only one disk, mirror flag is gone here, and also if you do LVS, same thing. But how about my data? Let me go to data, ls. I still have the data, so there is no issue. So that is the main purpose, that you have fault tolerance, and if something goes wrong in one disk, you have still data in your other disk, right? So this is it, guys. This is it for LVM mirroring, and same thing like I showed you, it will also help you when let me see those history. I said here in the beginning the benefits, where it is. Okay, so let me see where it is. Okay, I missed it. I'm not sure why it has not written here. Okay, here it is. So those are the basic 3 regions. So this will also give you the same thing, the same I have showed you here. When you are converting, so for example, currently SDE, the disk which is running this LVM, is from data center A, and the SDF disk you have assigned it from data center B. So in that way, when you mirror it, you will have sorry, you will have consistency, you will have disaster recovery, right? For example, if this data center down, you still have another data center and LUN is coming from this data center, so you are good. And the other thing is EMC LUN and IVM LUN, two different LUN, how to convert it. So here also same thing, the disk /dev SDE, which is an EMC disk, and now you wanted to remove your EMC disk from your system. How to do? Assign a new IVM SDF LUN in the system, mirror it, and once it is mirrored, break the mirror and remove the other LUN, EMC LUN, and give it back to them. So these are the three benefits which we have when we use LVM mirroring. So you can use whenever it is required. So I will suggest you to use LVM mirroring. It is very much useful, so you can use them. Okay, so for this video, I think this is it, guys. We don't have much here in LVM mirroring. If you wanted to see other options about mirroring, you can always go ahead and do a main LV convert and check those flags which is available and how to utilize them. So those flags you can use. So for now, I'm just closing this video. Please comment if you have any doubts in this video, okay, and also please subscribe my channel if you have not subscribed yet. And thank you so much for watching this video.